Look at question number 12. In this particular problem, we're going to be looking at how to generate exponential models, either growth or decay, using tables. So we have a table of values here, and we're going to be creating an exponential model. So the question reads, Mark bought a new laptop for $1,250. He kept track of the value of the laptop over the next 3 years as shown in the table below. Question: which function can be used to determine the value of the laptop for X years after the purchase? Alright, to get us started, we're going to write down what the formulas for exponential growth and decay are. So let's put that to the side, our formulas. This is for exponential growth and decay. Alright, there are two forms for exponential growth and decay models. The first is known as the factor form. Okay, so the factor form is given by y equals ab to the x. Alright, this is known as the factor form. It's a factor form because it's written in terms of the growth or decay factor. Okay, so for example, if the b value, this is known as b is the decay constant. Alright, oh sorry, it's the growth or decay factor. Okay, so b is the growth or decay factor. So which is which? If b were between 0 and 1, so if 0 is less than b and less than 1, in that case we're going to have a decay model. Alright, so this would be a decay model. And then if b were greater than 1, in that case we're going to have a growth model. Alright, so the value of the growth or decay factor basically tells us if it's going to be a growth or decay situation. Alright, so B is your growth or decay factor. That's why it's called a factor form. This is the form we're going to be using for this problem. If you look at all the format of the alternatives that we have, they are all in the form f of x equals some constant times the base raised to the x power. Alright, the other one is known as the rate form. The rate form is as follows. The rate form is basically y equals a times 1 plus or minus the rate raised to the x power. Okay, so this is the rate form. Why is it the rate form? Well, just looking at it, you can easily tell what the rate is. Or if you have the rate, the decay rate or growth rate, you can generate this model using this formula right here. All right. So if it's a growth scenario, if the output is increasing, in that case, you're going to have 1 plus the growth rate. Okay, so 1 plus r is a growth model. And then 1 minus r, guess what that is? That's going to be a decay model also. Alrighty? Okay. So that's that. So let's just put a side note here, something to note. The connection between these two, they're one and the same. Something to note is that your growth or decay factor b is equal to 1 plus or minus the rate, depending on if it's growth or decay. Alright? Okay, so let's look at what we have here. First of all, I'm going to show you the quick way to do this. And then we'll go over all the steps so that you can see how to do it in detail. So if you just observe what's happening here, you notice that years after purchase, we have 1,000. 1 year after is 1,800,640. What's happening is that the amount is doing what? Is it going up or down? The amount is going down, which indicates a decay. Okay, so it's decreasing, which indicates decay. So from that alone, we can know that the growth rate has to be between 0 and 1. Okay, so if you look at the options that we have here, option 1, the the factor here, this is going to be a growth factor. This is greater than 1, so this is a growth model. So it cannot be option 1 because of this. This is a growth rate right here. I mean a growth factor. And then if you look at option 2, this looks good because it's decay. Because 0.8 is between 0 and 1. And if you look at number 3, the growth factor, this is a growth factor because the base of this exponential term is greater than 1, so that's increasing, so that cannot be the answer. And this is a potential answer because the base of the exponent is less than 1, which indicates that it is a decay factor, which indicates decreasing. Okay, so just by looking at the base of the exponents, the base of the exponential terms, you can easily determine if it's growth or decay. So we eliminated 1 and 3 because the bases are greater than 1, which indicate growth models, and we kept 2 and 3. I mean 2 and 4. Now to know what the final answer is, just think about what was the original amount, the original price. The original price was $12.50. So whichever one has $12.50 and it's a decay model, answer is option 4. All right. So that's just a quick way to do it. Just look at the table. Is it increasing or decreasing? And then look at the initial amount and you can generate the answer. Alrighty. Okay, so let's go ahead and do it step by step. First things first, we have our formula already. The formula is y equals ab to the x power. Let's find what b is first. So b is your, in this case is decay, so it's your decay factor. To find what the decay factor is, you just simply take y2 and divide it by y1, or you can take y3 and divide it by y2. It doesn't really matter. So we're going to take 800 divided by 1000. This is y1, this is y2, this is y3. We're trying to figure out what are we multiplying by every single time. Okay, so this is 8 over 10. And you can write this in fractional form. Just move the decimal point one place to the left for both of them. And in decimal form, this is 0.8. Or you could do it with your calculator. 800 over 1000 will give you 0.8. All right, so this is the decay factor. All right, A is the original amount. What is the original amount? The original amount or original price was 1,250. So we'll just take these two values and plug it into the exponential decay model, growth or decay model, or the factor form of exponential models. Let's go ahead and do that. So we have the model again is y equals a b to the x. And then if we substitute for a, we put in 1250. And the base b, the decay factor, is 0.8. Raised to the x power. We can clearly see that our answer is option number 4. Okay, so that's that.